Hello viewers, welcome back to my channel. In this video I am discussing one of the most important question asked in various examinations. This is the very useful video and helpful for your exams like KSET and CSR NET and other entrance examinations also. The question given like this: the function f of x is equal to box of x, where box of x denotes the greatest integer function is continuous at. Okay, they given four options. Option A is 4, option B is -2, and option C is 1, and option D is 1.5. Okay, this is the question based on greatest integer function. We have to check the continuity of greatest integer function. Okay, this is the very important function. Okay, in this based on this type of function, questions asked in KSET and IIT JAM and other entrance examinations. Okay, I am detailedly discussing this function, and I am also giving some tricks also. Okay, in next video I am discussing greatest integer of x square and greatest integer of x plus 1 by 5 and greatest integer of x cube and greatest integer of root x. Suppose the given functions give the function given like this. Okay, how to find the continuity and discontinuous of these functions. Okay, in this video I am discussing continuity of this function. Okay, the definition for greatest integer function is the box of x indicates the integral part of x which is nearest and smallest integer to x. Okay, this is the integral part of x and which is nearest and smallest integer to x, or we also define like this: the greatest integer value x is a smallest integer from x but greater than all values. Okay, this is the definition for greatest integer function. I am giving an example. Okay, suppose we take the example, the greatest integer of 1.5. Suppose, what is the greatest integer of 1.5? They ask the question like this: find the greatest integer of 1.5. How to find? According to definition, what the definition say? The greatest integer value x is the smallest integer from x but greater than all values. Okay, this is the, suppose this is the x, 1.5 is the x. Okay, what is the nearest and smallest integer to x? What is the nearest and smaller integers to x? Tell me. One is the nearest and smallest integer, and 0 also near and smallest integer, -1, and like this -2, and so on. These are all the nearest and smallest integer. Okay, smallest small integers to 1.5. But among these all integers, which one is bigger? Here 1 is the bigger. Okay, this is the answer. Greatest integer of 1.5 is equal to 1. Okay, we first have to write down the all the nearest and smallest integer to this. Okay, this x, this is the x. Okay, this number. Okay, among all these integers, which one is greatest? Which one is greatest? That is our answer. Okay, I hope you understand. Suppose we take 2.5. 2.5. What is the greatest integer of 2.5? The greatest integer of 2.5 is 2, because we have to write down the nearest and smaller integers. 2 is this nearest and smaller integer, 1 like this, 0, -1. All these all are nearest and smallest integer to 2.5, but among all these integers, 2 is the greatest. 2 is the greatest. This is our answer. Okay, what is the greatest integer of -1.999? What is the greatest integer of -1.99? What is the answer? Tell me. What is the lowest integers of minus 1.99? Here minus 1, minus 2 is there, and minus 3, minus 4. These all are nearest and smallest integers to minus 1.99. Among all these integers, minus 1 is the greatest. Here answer is minus 1. Okay, and what is the value of 1.9999? What is the value of greatest? What is the greatest integer of 1.99? The answer is 1 only. Okay, what is the greatest integer of 1? 1 only. Greatest integer of 2? 2 only. And greatest integer of minus 100 minus 999? Tell me, what is the greatest integer of minus 100.99? The answer is minus 101. Minus 101. Okay, minus 10. The nearest and smallest integers what? Minus 101, minus 102, and so on. Among all these integers, minus 101 is the greatest integer. That's why this is the answer for this function. Okay, I hope you understand the definition of greatest integer function. Okay, now we have to in generally we denote like this: the greatest integer of x is always less than or equal to x only. Okay, now we can denote in graphical also. Observe here 1 2 3. This is x-axis, this is y-axis. 1 2 and 3, minus 1 minus 2 and so on, and this is minus 1 and minus 2 minus 3. Okay, this is 0. 0 to 1. 0 to 1 we take any value. 0 to 1, suppose we take greatest integer of 0 what? 0. Greatest integer of 0.1 what? 0 only. Greatest integer of 0.199 what is? 0 only. Greatest integer of 0.999 we take, the answer is 0 only. We take 0 to 1. 0 to 1, what is the greatest integer of 0 to 1? Tell me. 0 only. These are all points. Okay, and we get 0 answer. Okay, now we have to find the greatest integer of 1 is what? 1 only. 1 only. Okay, now greatest integer of 1 is what? 1. The point comes here. Okay, we take any value 1 to 2. In between 1 to 2 we get 1 only. Okay, here we indicate circle like this. Okay, here also we indicate circle like this. Okay, and like this is the point. The graph goes like this. The graphs go here also. In between minus 1 to 0, the greatest integer value is what? Minus 1 only. Here the graph we get like this. The graph we get like this. The graph goes like this. Okay, you understand now, I think. Okay, this is the graph of greatest integer function. Okay, now we have to understand one important point here. Okay, the graph goes on increasing, but this is not strictly increasing. This is the graph is the greatest integer function is increasing function, but not strictly increasing. Strictly increasing means what? The graph is goes like this. There is no constant values. Okay, this is the increasing function we called. This is the strictly increasing function. Suppose the graph goes like this, we get like this. We get any constant value we get. This is not strictly increasing. This is only monotonically increasing or increasing function we call. Okay, this is the nature of this function. This is the only increasing function, or we call as the monotonically increasing function. Okay, now we goes to limit of this function and continuity of this function. Now we have to discuss the limit of the function. This function is unbounded, so limit does not exist because we take the limit limit extends to infinity. The limit value is infinity only. We apply the limit at extends to minus infinity, we get minus infinity. Okay, these both are not equal. This is unbounded. This is unbounded because we get infinity and minus infinity and the limit does not exist. Okay, another point is limit at integers. We check limit at integers points. Integers means what? 0, 1, 2 and so on, and minus 1, minus 2, minus 3. These are the integer points. Okay, at each integer the right hand limit and left hand limit exist but not equal, so limit does not exist. Okay, let suppose we take the function is what? Box of x. We check at x equal to 1. 1 is the integer point. Okay, at x equal to 1 we take right hand limit. We take right hand limit. Suppose we check, see this, the graph is goes 0, 1, 2. Okay, this is 1, this is 2. Okay, in between 0 to 1 we check 1. Yes, we check at 1. We take right hand limit. We take right hand limit. We limit at x tends to 1 plus the greatest integer of x equal to 1, because we take 1 to 2. We take 1 to 2. We take any value. Suppose the greatest integer of 1 is what? 1 only. We get greatest integer of 1.1 is what? 1 only. We take in between 1 to 2. We get the values 1 only. 1 only. Okay, yes or no? We take 1 plus means what? Greater than 1, greater than 1 value, greater than 1 value, that is 1.1, 1.2 up to 1.99, 1.999. These are the all values comes at 1 plus. Okay, 1 plus means what? Right hand limit 1 plus. Okay, in between these, in between 1 and 2, okay, the all values value is what? The greatest integer of these all values are 1 only. That's why we get 1. That means what? Limit x tends to, suppose we convert into in terms of h, we get h tends to 0. 1 plus h is equal to 1 only. We take any additional value to 1. We take we add any value to 1 that is greater to 1 only, greater to 1 only. Okay, that means what? 1.1, greatest integer of 1.1 is 1, greatest integer of 1.2 is 1 only, greatest like this one, greatest integer of 1.999 we get 1 only. Okay, like this we take limit left hand limit also. Limit extends to 1 minus. Okay, left hand 1 minus means was less than 1, less than 1, less than 1 all values. Okay, all values less than 1. Okay, that means what? In between 0 to 1. In between 0 to 1. We take any values in between 0 to 1. Okay, all the values, greatest integer values, answer is what? 0. Okay, I hope you understand now. That means what? Limit h tends to 0. 1 minus h. Okay, we take any value h. Okay, we subtract 1 minus any values. Okay, in any values of h, we get what? Less than 1 only, less than 1 only. That means 0.99, 0.1, 0.2, 0.89, like this. These all values comes under 1 minus h only, 1 minus h only. The greatest integer of these all values what? 0, 0. That's why the limit the RHL is not equal to LHL. Left hand limit is not equal to right hand limit, therefore limit does not exist. Now we check at limit at non-integers. Okay, if we take limit at limit at non-integer points, the limit is exist. Okay, non-integers mean what? 0.1, 0.5, 0.05, 0.39. These all are non-integers. Okay, these all points are non-integers. Okay, if we take limit at non-integer points, the limit is exist, because suppose we take at x the function the f of x is equal to box of x at x equal to 1 by 2. This is non-integer function. 1 by 2 means what? 0.5. Okay, 0.5. Okay, we take left hand limit x tends to 1 by 2 minus at greater integer function of what we get? 0. Suppose we see the at here which we taken the graph. This is 0 and this is 1. In between 0 and 1 we 0.5 comes here. 1 by 2. Okay, we take 1 by 2 minus. Okay, we take less than values of 1 by 2. In between less than values means what? 0.1, 0.2, 0.111, 0.12. Okay, these all are 0.3. Okay, these all are less than values of 1 by 2. What is the greatest integer of these all values? 0 only. Yes or no? Okay, this is the 0. And like this, right hand limit also. See this, in above all values of 1 by 2. Greater values means what? We get 0.6, 0.56, 0.589, 0.7. Okay, these all are greater values of 1 by 2. Okay, in these points, all these points, greatest integer what we get? Again 0 only we get. Okay, that means what? At we check at limit extends to 1 by 2 also. Limit extends to 1 by 2, greatest integer of x, what we get? Greatest integer of 1 by 2, that is 1 by 2 only 0 we get. Greatest integer of 0.5. 1 by 2 means what? 0.5. This is equal to 0. Okay, that means what? Left hand limit is equal to right hand limit, therefore limit exists, and this is also equal to functional value of 1 by 2. Okay, this means what? The given function is continuous at non-integer points. Okay, and this is not at integer points. This function is not continuous, because if limit not exist, the continuous also not exist. The given function is limit not exist, then the function is not continuous. If the function is not continuous, okay, then the differentiability also not exist. Okay, this is the link. Limit not exist, that implies not continuous, that implies not differentiability. We have to remember this trick. Okay, in any exam we check limit. If limit does not exist, the function is not continuous also. If not continuous, the function is not differentiable also. Okay, if suppose limit exists, we can't say anything about continuous. Okay, we have to check it. Okay, suppose if continuous exists, we can't say anything about differentiability also. We also check by using formula or something. Okay, we have to check differentiability also. This is the trick we have to remember. Okay, this is the overall concept of continuous. The continuity at integer. This function is not continuous at integer. Okay, in all integer points 0, 1, 2, 3, the given function is not continuous. Okay, and this type of discontinuity is called jump kind discontinuous. Jump kind discontinuous means what? Left hand limit and right hand limit exist, but both are not equal. This type of discontinuity we call a jump discontinuity or jump kind discontinuity. Okay, continuity at integer. This function is continuous at non-integer points. The function is in between I accept 0 and 1. This is open interval. Okay, this is open. 0, 1 means what? At except 0 and 1, in between 0 and 1 all the points exist. Okay, except 0 and 1. okay, at 0 and 1, and that means what? Integer point. At integer points the given function is not continuous, but except integer points, in all non-integer points the given function is continuous. Okay, this is the point we have to remember. Okay, this is the overall concept of continuity. Okay, we can tell continuity and differentiability in through graph also. See this, if the given function is continuous, the graph is there is no gaps in the graph. That is the continuous we tell in the graphically. Suppose we get any gaps in between. Suppose the graph is goes like this, we get gap here, and the graph goes again like this. This is the we called as not continuous. Okay, like this also we see this. Here we get gap. Okay, here we get gap, here we get gap. At all the integer points we get the gaps. Okay, at all the integer points the given function is discontinuous. Okay, this is the not continuous. Okay, now we have to come to we can answer this question directly if you know all these points very well. Okay, the function f of x is equal to box function, where the box function denotes the greatest integer function, is continuous at what? The given function. This box function is continuous at non-integer points. This given function is discontinuous at integer points. See this is integer, this is integer, this is integer. These three are not our answer. This is our answer. 1.5 is non-integer. This is our answer. Suppose in the question they given like this, the function f of this function is discontinuous at, if the given function is discontinuous at 4, -2 and 1. Okay, for this question this is our correct answer, 1.5. Okay, I hope you get the all points regarding greatest integer point. In next video I am discussing this type of questions. Okay, continuity and discontinuity of this type of questions. The questions asked like this also: sine of greatest integer of x, and greatest integer of sin x, and greatest integer of cos x, and greatest integer of algebraic function x cube. Like this the questions asked like this. In next video I am discussing briefly and I will give in next video I am giving only tricks for these questions. Okay, in all the points regarding greatest integer function in this video I am covered. That's why in next video I am giving tricks for this type of functions. Okay, I hope you like the video. Please subscribe my channel and share it to your friends, and comment your doubts regarding this function. Thank you.